I'll try to share the screen then.
Sure, yeah, that'd be great. It's my pleasure to introduce Dr. Jay Lund. He's a professor in civil and environmental engineering at UC Davis. His research is in systems analysis and water resources and environmental management. Really well known for developing large-scale optimization model for California's water that's been applied to address a number of questions. And so really excited to hear whether the drought's over. So I'll pass it off to you, Jay. Thank you for being with us and sharing this.
No, the drought's not over. Okay, seminar's done. All right, so thank you very much for having me talk a little bit about drought and this drought in California, because it's not over. So you'll get to hear some speculations on what might happen with it. And there's a possibility that during the remainder of this wet season, the drought might be ending, but I don't think it's likely. Can everybody see the slides? Okay.
Yes.
If you like the kind of stuff that's in this presentation, you can go to californiawaterblog.com, and every week we produce a 1 or 2 page snippet on California water problems from all sorts of different perspectives: ecological, engineering, economics, geology, all sorts of interesting stuff. Just a little bit of an outline for the talk today. I want to give people a little bit of an introduction to California water, although I'm suspecting most people here don't need very much of that. Talk about this drought so far. We're in the second year of this drought. Talk a little bit about portfolio management, which I think is the best approach we have to preparing for droughts in California. And it's an approach that's been quite successful, where it's been able to be applied. Talk a little bit about how we've gotten better with droughts over time. One of the main arguments I'll make is that California has this highly variable hydrology. We have lots of floods and we have lots of droughts. And because we have a lot of droughts, it gives us a lot of opportunities to improve. And we have in fact improved from year to year. We still have a terrible time with droughts, but not nearly as bad as we used to, and probably not nearly as bad as we should in the future, although climate change is the wild card of that, and it might make future droughts worse than in their impacts on what we have been seeing. And then I want to end with some discussion about what happens if this drought continues for another few years. Just as background, something most of you are already familiar with. This is a map of California's runoff. You can see where it comes from in the north and in the mountains. And you can see where it doesn't come from in the deserts and in the south. For scale, this is my home state of Delaware and the state of Israel, all very small places. California is a really big place. And of course, where do we put the people, and where do we put most of the agriculture in California? We put it where the water ain't, both in time and in space. And so what we've had to build on this map on the right is a tremendous amount of infrastructure owned and operated by lots of different institutions, which sort of get along with each other much of the time, but oftentimes don't. We have all sorts of groundwater, surface water, reservoirs, aqueducts, pipelines, canals. We reoperate rivers, levees, all sorts of stuff. So this is a wonderful place to be a water engineer, I have to say. It's been very good for me professionally, and all the students. So not only do we have this very interesting hydrology of the water is in a different place than the people and the water demands, and not only is the water available in the winter and we like to have it in the summer, so we have a seasonal mismatch, but we also have a lot of variability from year to year, which is particularly important for droughts. So this is a map that shows the annual coefficient of variation for precipitation across the country. And so you can see back here in Delaware, where I'm from, it's very boring. Whereas move out west, it starts to get bigger and bigger, and then you get out to California, and it's absolutely weird. Just like people back east, we're always saying about California. It's a weird place. Hydrologically, it's definitely true. And of course, even within California, it's even weirder in Southern California, which I think is something most people would agree to. The way I like to put this high coefficient of variation is that California has more flood years and drought years per average year than any other part of the country. So we're always managing for extremes. And with the changes in climate, most of the climate models seem to indicate we're going to see more extremes. So you could almost say that California's climate is going to become more like California's climate than it is now in terms of high variability, high coefficient of annual variation. California has a lot of droughts. So this is the historic record from late 1800s to now. You can see lots of droughts the whole time. Maybe a little bit more frequently having droughts in the last few decades, but I wouldn't want to try to prove that statistically. But, I suspect that if you tortured the statistics enough, you could get them to say that, but it would require, I think, a little bit of torture. If you go back and look at the paleo record, the last 200 years of our experience have been relatively wet compared to paleo records of drought in the West and in parts of California where they exist. So again, California's climate, the West's climate as a whole, has high interannual variability and certainly high variability between months as well. And so we see periods, very long periods of hundreds of years, where we had much drier conditions than we have experienced historically. Now, people living at that time would have experienced that as climate change. And I think we are having climate change now, but it won't be the first time that people have experienced climate change in the West. So what have I said so far? I've said California has a lot of droughts. California also has a lot of more than just a dynamic climate. It has a very dynamic society, very dynamic economy as well. And sort of think back for the last 100 years or 200 years that we've really seen tremendous changes in the economic structure of our economy, the populations, the composition of the populations, our life expectancies, our wealth, and our uses for water. What we really gain from managing water in California, or what our objectives are. One long-term aspect, I think, of water management in California is that California has a globalized economy. Our economy of California has not been subsistence-based for the most part for a very long time. I was rereading Richard Dana's 2 Years Before the Mast, which was written in the 1830s. And even at that time, the ships that came to California were picking up hides to take all over the world. And certainly much of California's agriculture and water use are motivated by really California's involvement in the global set of markets. Economic structure of California drives most of the human water management for agriculture, for cities, for producing things, for recreation, all the like. Droughts are pivotal events in the history of water management. So imagine you're managing water every year. You like to do the same thing every year, but the economy is changing underneath you. The society is changing underneath you. And so over time, what you want to manage water for is changing, but the way you manage water tends to stay the same. And then you get into a drought or a flood, and you start to see the benefits or the need to make changes in your water management. And so throughout the history of California, droughts and floods together, as well as some lawsuits, have been really pivotal events in helping us improve the management of water over time. We adjust not only sort of management and sort of operationally, but we also alter the technologies we use for water management and the institutions we use for water management. So you tend to see major water legislation, say sigma, correlate with the occurrence of droughts, for instance. And so we're always adjusting the technologies, the institutions, the infrastructure, the management, if you will, the operations over time, punctuated by these floods and droughts. And over time, we also tend to rebalance the portfolio of water management and the responsibilities of different levels of government. So if you go back into the 1800s, most water management was done locally. There was almost no state and federal management. When the local activities reached their sort of saturation for the technologies of the time and the water demands of the time, we went to building bigger reservoirs and things like that. And that required state and federal involvement. These are a little larger scale of institutions. Now that we've largely built most of that infrastructure, that we're seeing diminishing marginal returns. I'm trying to use economics lingo because I know there's an economist here. We're seeing that we have some new technologies, some new approaches that often have a higher returns to scale. And so water conservation, water marketing, groundwater conjunctive use, things like that tend to have been adopted. And those sort of newer technologies in the mix, the local governments tend to have more comparative advantage in operationalizing those than the state and federal government. So we see a mix of these institutions over time evolving as well. Let's look at the current drought. The current drought is 2 years old, started in 2020, not 2000, but 2020. Sort of a mild drought year is the 9th driest year of record. And then next year, this last year, water year that just ended, 2021, was the 3rd driest year in terms of precipitation in more than 100 years of record. So a really dry year. Not the driest year in terms of precipitation, but definitely one of the driest. We also had much warmer temperatures than historically, similar to the previous drought, the 2012 to 2016 drought. And that has higher temperatures increase the evaporation off the landscape. They make the soil moisture go away faster. That accelerates the onset of the fire season, increases the damages to forests and the like. So a lot of the damages of this drought and the previous drought are coming from the higher temperatures and not just the lack of precipitation. And so when we have higher temperatures on top of the 3rd driest year of record, and it's the 2nd dry year in a row, it really magnified the drought impacts by quite a bit. These warmer temperatures made the runoff in year 2021 much less than they were forecast to be. So based on this past statistics of many years, the Department of Water Resources was fairly confident in forecasting about 700,000 acre feet of runoff that actually didn't occur this year. And so that was hard felt, I think, by quite a bit, quite a few water users. This is definitely a major drought so far, but I don't think it's the worst drought of record yet. And as we saw in October, here in the middle of this drought, we have one of the wettest 2 days of precipitation in more than 150 years of record. That really illustrates California's hydrology right there, that we can have very wet and very dry in the same year. We always have to worry about floods and we always have to worry about droughts. This next chart shows California's climate, it's Mediterranean climate. So you can see our water year begins October 1st. Just like people have a fiscal year, calendar year, we have a water year that starts October 1st. We get to have another New Year's Eve party. The current year, you can see in blue here, we had this huge storm in October, the end of October, and making it probably one of the wettest Octobers on record, if not the wettest October on record. Right now, we are at probably a little bit less than 200, 300% of average for this time of year. The most operable phrase being for this time of year. Again, as I said before, the amount of precipitation was about half of what all the water we received, all the precipitation we received in all of the water year 2021. So a really good walloping, but not a lot of runoff. It was enough to start the reservoirs to start to refill a bit, not hugely yet, but I think it didn't moisten up much of the soil moisture in the northern part of California. Compare that with some of the other years. You can see the two drought years here. You can see each individual storm adding steps to the cumulative curve. You can see the difference between the wettest years of record, this green line, and the driest years of record are in the number of steps and the size of the steps. So get big atmospheric rivers like this one, brings in a lot of water, or a number of smaller ones bring in less water. And then by basically beginning of April, middle of April, you sort of run out of new storms coming in. And it's pretty dry after that. So all of these tend to plateau. In terms of reservoir storage, it's been going down. So this is end of last month. We have percent of average numbers are pretty low. San Francisco Bay, it's a high number, but that's because it's local storage. And it's a small amount of storage there. You look at the green rows here, where the big storage capacities are. These numbers are down at about 2/3, so not very high. And as a percentage of capacity, quite a bit less, because we need to keep them fairly empty at this point of time of year for possible flood flows. You go down to the Colorado River, where there's a huge amount of storage capacity. It's been going down for, I think, since 1982 or so, and now is about half of average for this time of year and about 1/3 of capacity. So I think that part of the world has quite a bit more to worry about even than we have from this drought. But the numbers are all pretty low. We just got out of the second very dry year, and so if we go into the next year, that reservoir level's only going to increase if this year is wet. This is another way of showing that for California. Some of the different reservoirs, you can see the blue lines of where we are now, or at least we were in the mid-October. Reservoirs are dry. Let's look at the structure of the economy over time. So this looks at the percentage share of California's employment in mining, agriculture, essentially industrial goods, non-recreation services and recreation. Back when we were founding our water law, it was a mining economy. Back when we were building and planning most of our water infrastructure, it was an agricultural economy. Now we're mostly a service economy. And it's a really good thing because the service economy doesn't need nearly as much water to make money as an agricultural economy or a mining economy. So this change in economic structure for California and the globalization of that economy, I think, is very, very important for reducing the vulnerability of California's economy and the people of California, most people in California, to drought. And it explains in part why we can still have a lot of economic success despite what is hydrologically a fairly severe drought. We have a lot of changes going on in California water. Certainly climate changes, sea level rise, warmer temperatures, more extremes, perhaps changes in precipitation. We have deteriorations in aging infrastructure, accumulations of salts and nitrate, legacy mining. We still have a lot of acid mine drainage in parts of the state, groundwater overdraft, earthquakes, the Sacramento San Joaquin Delta and its land subsidence. A lot of deterioration that's accumulating and that we have to manage with over time. The economy and demography are changing. Certainly the ability of state, federal governments to finance things. It was way down for a while, but we might have a few years here where apparently people like to spend money from the state and federal governments. Globalization, I think, is continuing to affect a lot of California's economy, and mostly for the good, I think, of the economy. We have less population growth than we used to have, and probably less than we anticipated for many of the urban areas at one time. And I think we probably still have, on balance, some urbanization going on for the population as a whole. Ecosystems have seen tremendous changes, and I think they're going to see quite a few more changes, particularly with the warmer temperatures and changing climate. A lot of new invasive species continue to show up, both for agriculture and in the general environment. Wildfire and forests changing their composition are tremendous as well. Some general, just continuing degradation in general of native ecosystems. Then on science and technology, we have a lot of new chemicals, pesticides, things like that to worry about. And we have a lot of new technologies that help us out and confuse us, like new sensors and computers and GIS, and some things that are really very helpful. To adapt to this land of extremes, where we have a lot of economic activity, a lot of people, very high standards of living for the most part. Most of the state, certainly the more successful agencies, have adopted a portfolio water management approach, where you're developing infrastructure that's not just storage, or not just storage and conveyance. And you connect to a very large network of people that can help you, and you can help out under different conditions over time. And so this is a map of the schematic of the statewide water system. It's also the schematic of the model we have for the system. And what this allows us to do, sort of, maybe not all of the above, but much of the above, in terms of managing both a wide range of supplies, a wide range of demand management activities for a wide range of water management water demands, that to help us sort of knit together lots of different activities to have a more cost-effective and a more reliable water system overall. We still would like to have more water. We'd like to have more water for free, but given that we're going to be having water scarcity in California probably forever, it does help us manage that scarcity much more effectively than we would if we felt we had to build to exceedingly high reliabilities. This management approach has been very successful, but it has taken a lot of time to organize, and it's very noisy because all these people have to get along with each other in public, and sometimes they don't in public, but they get along with each other better in private. So we always see a lot of lobbying and advocacy in addition to the cooperation. You tend to hear more about the conflicts and the cooperation, but there's a tremendous amount of cooperation that occurs in this system. Just to further accentuate this idea of a portfolio approach, you can see a lot of the water supply activities that all help smooth out availability and make lower quality water into higher quality water, things like that. We have an equally diverse range of water demand management activities that can be used. And because these portfolios involve not just one agency, they involve a lot of different agencies, and they involve the water users and the water demand decision makers, the households and the farmers. the portfolio also includes a wide variety of incentives to help people work more effectively together, such as pricing and markets and norming and shaming and all kinds of subsidies, insurance, all kinds of things. So it's really a pretty diverse range of activities, and the water manager's job, and I think increasingly the water scholar's job, is to look at, well, how do you put together promising portfolios to adapt to these kinds of conditions that California has and California will find itself more susceptible to in the future. These portfolio activities occur locally with individual water users, with local water districts, local water utilities, as well as statewide and regionally. And so increasingly, I think our problem is how do we integrate a mix of these activities to go well together. We have some special problems, such as the delta, which is not very stable geologically or for the future with climate change. It's not very stable in terms of its ecosystem, and it's not very stable in terms of its economy. And that it has a lot of land that's well below sea level, and much of that land is not in highly valuable economic activity. So that for many of the islands, the most subsided islands, if they flood, the business case for repairing those islands is not very favorable. Not in every case, but in many cases. We have some problems with rural drinking water. 1 to 2% of the population living in rural areas is susceptible to nitrate contamination, and their wells going dry in drought years as the surrounding agriculture pulls the water down in order to keep the agricultural economy of those regions going. It's a very difficult position for these poor communities to be in because their employment relies on the success of the agriculture, but the drinking water supplies rely on the agriculture not pumping too much. So far in this drought, most people and most economic activity have been pretty well insulated from the drought, particularly in the urban areas where there's a pretty effective water portfolio approach being taken, and in many of the agricultural areas. The ecosystems, I think, particularly the forest and the aquatic ecosystems, winter run salmon in particular, have been really hammered. I think we probably lost all of the naturally spawning winter run salmon this year, almost all of them. Agriculture in some areas is suffering, but mostly without catastrophe because of increased groundwater pumping. The rural areas are seeing again some more dry wells, both with individual households in rural areas and small communities because of the additional groundwater pumping. Another big and new change for this drought is that all of that increased groundwater pumping that we have for this drought is going to have to get repaid under the Sustainable Groundwater Management Act. It's going to count against the overdraft in those basins. What that's going to mean in the long term is there's going to be more fallowing of agricultural land in wetter years in order to reduce the pumping and increase the recharge so that there's water available in those basins during dry years to be pumped. This is a tremendous change from all previous droughts. And I'm not sure that the agricultural water users have completely come to grips with this. It would be ideal if we had only wet years between now and 2040 when the sigma requirements have to be met. An additional dry year is going to could make this drought a real whopper. Many of the urban areas are preparing for additional dry years, but I think we have some long-term preparation gaps in terms of ecosystems, the delta and wildfires. But we're going to have challenging times for California water again, because we have this naturally high variability. We at the university have been developing water models for all of these things that try to give some insights. Certainly we have here, and UC Merced has some folks doing some good work in this area as well, and I'm sure they're not alone in the rest of the UC system. And there's a lot that can be learned from these kinds of technical studies. I won't go too much further into it, but it really does force us to develop a coherent, integrated technical and economic understanding of these things. I see some reasons for hope in the long term for California because, for the most part, human water use has peaked. We might see diminishing water supplies. That means that we haven't peaked relatively to the water supplies, but in terms of absolute use in urban areas, I think we've probably peaked statewide anyway, not all local areas. The economy continues to be less reliant on abundant amounts of water. We're using water markets more effectively to shift water use and to civilize the changes in water management that need to be made over time. That'll be a bigger, more valuable innovation in the future, I think, as the climate changes. And we all agree that we have a problem. Another consolation in my thinking on this problem is when I look at the cumulative number of jobs and revenues created by crops in California, that basically 85 or 90% of the agricultural revenues and agricultural jobs in California come from about half the irrigated area. That makes me, that means if you get really stuck with overdraft or with droughts or climate change, if you properly allocate that shortage, you will suffer. Fewer people will suffer than if you allocated that water poorly. So, and we have a very similar shaped curve for the urban areas, where about half of the water use is for irrigating our lawns and our landscapes. Again, very low value in terms of jobs in an aggregate sense. And certainly there are people that work in those sectors, and certainly they will be hurt by these shortages. But the rest of the economy, if it remains healthy, can help those people out. And I think that's probably the most economical way to look at this, most adaptable way to look at this for a changing climate and changing conditions. Our traditional drought thinking has always been, we have a water shortage, we need to build something. Not that we have a water scarcity that needs to be managed. I think we have to look at it as water scarcity that needs to be managed. I have a wonderful colleague, Richard Howitt, used to say, there's a shortage of sports cars, I don't have one. And that, there's really not, very rarely is there a shortage of water, but there's usually a shortage of cheap water. So more of our water supply traditionally would come from building things, which has become very expensive, and it has diminishing marginal returns. The traditional ways of thinking about drought also have this idea of waste. And usually, almost always, waste is water used by somebody else. And that's not a very productive way to argue through it. So I think we're probably all pretty aware of the limitations of that kind of traditional thinking about drought. It really narrows the options that are available. It reflects really unrealistic expectations for the nature of the resources and how we have to manage it over time. And it's more advocacy oriented rather than problem solving oriented. And so sometimes it doesn't really help solve the problem in the long term. We have new challenges with the current drought and coming droughts, higher temperatures, depleting groundwater quantity and quality. So wetter years will be needed to balance the drawdowns that we want to have in drier years. We're going to have some accumulations of salt over time that are going to make that more challenging. We have diminishing and changing ecosystems. And we have some very, I think, deep philosophical and practical struggles about how are we going to try to keep those things alive and going. We have a lot of interest in social justice, rightly so. And we have some systems that are very difficult to manage just because they have small scale and they're remote and not particularly well organized for rural drinking water. Those communities have terrible drinking water problems in many cases, but that's not the only problems they have. They have problems with sanitation, they have problems with police and fire and education and lots of other areas. So I think we need to look at these problems more holistically and really try to do right by these folks in a broader sense, not just sending them bottled water. That seems like a cowardly way out to me. And then we have climate change and really changing nature of droughts. New drought thinking, as you might surmise from what I've said already, it uses portfolios for water management, for supplies. Wide variety of sources, interties, water contracts, water markets. You match these portfolios with a portfolio of water demand management, of permanent conservation, drought conservation, paying others to reduce water so you can use some of their water or use some of their aquifer by having people irrigate less on their lawns or paying farmers to fallow lands in dry years, things like that, or permanently. Rural drinking water and SGMA need immediate help, and then groundwater implementation with SGMA is going to need quite a lot of help. There's some really nice evaluations that are coming out that are forcing us to think more about how SGMA is going to be implemented and how we're going to manage drought in the middle of all that. Forest and droughts, I think from the last drought, that turned out to be a really big, important thing. We had about $9 billion worth of traditional economic losses from the 2012 to 2016 drought. We had several wildfires after that drought that were made much worse because of the drought, each of which had about 10 or $20 billion worth of property damage and loss of life and disruptions to life due to air quality. So we're seeing, I think, is that the newer droughts, the future droughts, might have more deaths and more economic impacts from the air quality impacts than from the traditional kinds of things that we've been worried about. Ecosystems, those are tremendously important. We really have barely started to think seriously about how to manage ecosystems through droughts. And that's a real challenge for all the students out there that are going to have this as something they're going to have to figure out and be responsible for in their generation. Because the previous couple of generations haven't done particularly well with this. And we should be preparing for worse droughts, I think, not just the drought of record. Droughts have evolved tremendously over time with the changes in the economic structure. Again, the economic structure drives the water demands, it drives the kind of economic damages you see from droughts. As we've gone through different droughts in the past, you've seen swings in the portfolio, swings in the different initiatives taken by different levels of government over time. All very important, considering the portfolios of things that were available, the relative economic advantages, relative returns to scale of different kinds of technologies and institutions at different times for different kinds of water management activities. The drought, today's drought, as of today, we've had 2 of the driest years of record with record high temperatures. We had a huge atmospheric river with a record 2-day precipitation in October. This was followed by November, which has been very dry. And has very dry forecasts for the rest of the month. This is all very like California, it seems. More like California than it has been historically. And our reservoirs and groundwater are low because we've had these 2 very dry years coming in. What could happen next? If this this winter is average, we have low reservoir and groundwater levels that will basically, I think, carry the drought into the next year. So even if we get average precipitation, we will be going into next year with low reservoir levels and low groundwater. And so we should probably expect to be considered still in a drought. We're going to have continued problems, I think, therefore, with agricultural water deliveries because the allocations will not be particularly high, with rural drinking water wells because the agriculture is still going to want to pump groundwater, and with many of the forest and aquatic ecosystems. This additional overdraft from 2020 to 2021 and an additional overdraft likely in 2022 is going to have to get repaid under SGMA. This is going to put further pressure on the GSAs and the state board and DWR to really press for permanent fallowing of substantial amounts of agricultural land, between 500,000 and 1 million acres statewide, mostly down in the San Joaquin Valley. essentially we're going to need a wetter than average year just to have an average water year in terms of water deliveries. If this winter is wet, we can probably expect to see some uneven recovery for ecosystems and drinking water and agriculture. But it's going to have to be considerably wetter than average, I think, to make up for the deficits over the last couple of years. If this winter is dry, sort of not the worst case, but towards the worst case, we have low reservoir levels, low groundwater levels. It's going to reduce the options for additional drought years. Our buffer is diminishing. We have much more severe threats to the ecosystems and agriculture and rural drinking water wells. It's greater problems for the San Joaquin Valley, in particular, is compliance with SGMA and the need to follow agricultural lands. Growing problems and risks for urban water supplies. Urban water supplies have invested tremendously over the last 20, 30 years to give them very reliable supplies. But we're likely to see locally mandated cutbacks and perhaps statewide mandated cutbacks in urban water use if this coming year is also dry. And we're likely to see delta salinity barriers, all kinds of innovative things happening as we struggle more desperately and with greater innovation to secure water for the highest value water uses. And we're going to struggle over what we want to consider to be high priority and high value. In the long run, we have to expect California's water system to change. So this is my Borg slide. Resistance is futile. We're going to see some flooding in some parts of the Delta, no matter what happens with drought, no matter what happens with climate change and everything else. We're going to see reduced Delta diversions very likely. We're going to see less irrigated land in the southern Central Valley, less urban water use, more stormwater reuse, capture. Some native species are going to become unsustainable in the wild. Funding solutions will be mostly local and regional because that's where most of the expenses are and that's where most of the money is and always will be. Nitrate contamination of groundwater is inevitable. We're going to have terrible troubles, expanding terrible troubles with rural groundwater water quality for drinking water. Groundwater will be more tightly managed. I think that's going to happen with SGMA, and it's going to be more painfully managed because it's going to require quite a lot of land fallowing in parts of the state. And the salton sink will substantially be restored, meaning that we're going to lose some of the salton sea. It's going to continue to shrink. We cannot drought-proof the state. We're going to have to manage with it. We've been pretty well compared to other Mediterranean climates. We've done very well at managing our problems relative to other Mediterranean climates. But in an absolute senses, we can all identify things where we would like to do better and we need to do better. So I don't want to encourage complacency. We're going to have to make some big changes, but we've also got a fairly good track record relative to other parts of the world at managing scarce water supplies fairly well. Sort of nearly a closure slide here for those of you that like to follow El Nino. This is the correlation of El Nino with stream flows in Northern California. I'm not going to do the statistics on this because there aren't any really. Don't listen when people talk about El Nino, they're just blathering. Then because I'm a professor, I'll give you some further readings. So that's it. Thank you very much.
Thanks, Jay. That was a nice overview of what is happening in California's water. And the future is not looking very good.
Well, it's good and it's not, right? We're going to have a lot of agricultural prosperity. We'll have a lot of urban prosperity.
Yeah.
Even when we run the most dire climates that we can imagine through our models, we still see people, the cities basically continuing largely as they are. They use less water, but it doesn't blow up. Los Angeles does not dry up and blow away. Agriculture diminishes tremendously, but it still keeps most of the high value crops. And so there's still quite a lot of agricultural prosperity left. The ecosystems, they really suffer.
Yeah, yeah. I wish they can speak like us. But anyway, I think, just coming back to the Q&A, and we have several interesting questions and comment in the chat, and I'm just going to read one by one.
Okay.
So the first one is, don't all the service providers need to eat, including those who use products who live elsewhere? And this is with respect to your figure where you were showing the economic values of different sectors.
So Dan Summer, who's on this, is probably in a better position to answer some of this than I am. But my impression is that most of the food I eat came from outside of California. And a lot of the most profitable crops we grow, we export mostly. So again, this is where globalization has really saved our bacon, so to speak, in that California's agriculture is much more profitable because we export so many high value crops and we're not a subsistence economy. We don't rely on the production within California for much of our consumption, certainly.
And in particular, Jay, our bacon is not bacon, is it? We don't produce any pork in California to speak of, but
That's right. So that goes to show the point, I guess.
and as Dave Block will tell you, our bacon's going to be coming from fungi pretty soon anyway. So there you go.
Yeah, but I think the question remains, right? In terms of our water footprint, when we assess the economic values of different, sectors, right?
Yeah, but that's just a silly approach to start with. You don't assess the value of a sector. People buy things, and what they buy, they'll buy, and what they don't buy, they don't. And this is where I would disagree with Jay. If people want to have a lawn in front of their house and they're rich, they will. And, we could disagree with the whole structure of the economy and say we'd rather have, I don't know, the governor deciding who eats what and whether we eat bacon or not in California. But most of us don't do that. That's not the way the economy works. And people will buy stuff. And I personally walk to campus, and so that makes me moral in some measures, but on the other hand, not in others, because I drink more water because I do that, I suppose. Anyway, so
Dan makes a really
it's like
good
people
point.
calling some crops more valuable than others, as though there's some moral content to a crop. Maybe, but
To me, the moral content is I don't want to see rural poverty.
Yeah, well,
I'm really not interested in having low value crops grown in rural areas when higher value.
I don't even know what low value means there, Jay. So I grow alfalfa and it feeds dairy cows, and they hire a bunch of people to milk cows. You just have to be really careful there.
No, I think that's fine.
And we all know that agriculture employment is tiny in California relative to every other job in the state.
And in terms of the lawns, I agree probably more with Dan than he realizes, in that for many environmental problems, I would rather have the money from the urban areas than their water use. I think you can probably make a lot more environmental improvements with their money from rich people that want to have their lawns.
But I absolutely agree with you, Jay. The more we can allow water to flow, the better. And that's really what your message was. Let the water flow.
Yeah. Okay.
And it even flows uphill if you pay it enough.
That's right. Sorry, go ahead.
Water always flows, where the money is. So anyway, the next, I think, is comment. Let's please talk a bit more about economic value of urban landscape. Not sure that you want to comment anything, Jay.
Well, if I can ask the question, which was from Dr. Lund's 2018 paper, where you wrote that those mandated cutbacks were accommodated in urban areas with very little economic damage, but that's only because we place no economic value on the destruction of urban trees, for example. And so when you have a park where, once you had trees, then the water goes off, now the trees are dead.
Very natural approach to looking at it. What has really surprised me and shocked me was that there aren't any economists in California that have published such studies. I mean, this is an opportunity for young economists to really make a name for themselves and bring some better numbers to this thing. But the fact that they didn't indicates that even the economists didn't think it was highly valued enough to do the numbers on it. And I would really like, because I agree with you. I think there are values for trees. There are values for green landscapes. Certainly you could do some sort of nice hedonic pricing kinds of things and estimate what are people willing to pay to have landscapes that are green. But I was kind of shocked after 2015 that I haven't seen any studies that came out of that.
Yeah, there's a lot more that can be done.
Yeah, more research is needed, as always.
If you're a student looking for a project, there you are.
It's a great one.
All right, the next question. What is your dartboard guess at the maximum time from now when we will have a major Delta Island meltdown and therefore salination of the California aqueduct and federal intakes pumping plants?
Sometime in the future. I mean, I think it's likely enough that to happen, because that's what a lot of the technical people say. But I also look at the investments of the big urban water agencies in having contracts and stockpiles of material, so that if that kind of event happens, they can shorten the duration of its impact on their water supplies. So
Yeah.
I think there's a fair chance that it could happen. It's likely enough that smart people are basically investing a lot of money preparing for that contingency.
Yeah, I know. I mean, the earthquake and land subsidence, related infrastructure failure has been talked about a lot, but the issues around the sea level rise and what could happen to federal and state project is a really big one. Yeah.
A lot of times these things never happen until they do.
Yeah. Okay, the next one is a comment. Says, I disagree with your classification of desalination as traditional thinking. The Israelis have largely supplied their water use through desalination. The coastal deserts and urban areas could drive their water from the source. A recent report from Stanford and MIT suggests this as a use for power from Diablo Canyon. And I don't have much understanding of the last comment, but
yeah,
you do.
Certainly the Israelis and in some parts of Australia, they rely on seawater desalination for a substantial part of their urban water use. And then they use the treated wastewater from that urban water use for agriculture. And that makes economic sense in a part of the world that is that dry. I don't think California is that dry yet. I would much rather have that money spent on reducing student tuition and helping the environment than on providing what will be a small fraction of California's urban water use at a very high cost. I just don't think it's a good investment from a policy perspective.
This is Steve.
If you were Saudi Arabia or your Qatar or your Israel or your Bermuda or your Perth, Australia, then I think you can make a reasonable case for it. But I don't think we're there yet in California.
This is Steve. I made that comment, and I think your estimates of the cost of desalination have been going down. The state's going to idle Diablo Canyon, which is a low carbon power source that could be used fairly cheaply for desalination, and the amount of water that's potentially producible is in the millions of acre feet. And the costs are not unreasonable given current urban water costs, at least that there is Israeli experience.
I think it's make a proposal.
San Joaquin
That's what I
Valley
show it.
are also substantial.
Show it. Do the numbers. Show it.
Okay. You can start with the MIT.
I can be convinced on all these matters if you develop a reasonable set of numbers. I'm a numbers guy.
Got it. All right, moving on. The next question: how successful has managed aquifer recharge has been during the last 5 years? How many acre feet have been stored by this approach?
It depends on where you are. Certainly in Southern California, they do a lot of recharge of wastewater as a form of long-term reuse, indirect potable reuse. I think that's really important in that part of the world where the alternative use of that wastewater is to send it out to the ocean. In the Central Valley, all of our wastewater is essentially reused as part of the hydrologic cycle. If you discharge it, if it infiltrates into groundwater or you discharge it into a river, somebody downstream is likely to pick it up, most of it up. We had some small amount of additional recharge of floodwaters. Many of the groundwater sustainability agencies and many people in DWR are banking on huge amounts of additional recharge of floodwaters to solve the groundwater overdraft problems. When I look at the numbers, I only see like, maybe 10 to 20% of the 2 million or so acre feet a year of long-term overdraft being made up by, additional recharge of excess or surplus or flood surface waters. I think it's largely an oversold solution, but it's useful, very useful. Often it will be economical, but we have some really much more painful things to contemplate in terms of fallowing substantial amounts of agricultural land, unless you find a magical solution that allows you to take an additional 1.5 million acre feet a year out of the delta, which I don't see that happening.
Yeah,
At least I want to make an argument for why that's reasonable.
Yeah, increasing the supply, but at the same time, don't forget to cut down the demand side. Yeah.
Yeah, I mean, the demand side is you got to reduce pumping. You got to fallow land.
Yeah. Okay. The next question is probably the last question, given the how much time we have left. I would be interested to know how much urban water use could be saved yearly if there were real incentives to remove turf, Bermuda grass, and replace it with native plants. So many co-benefits for ecosystem pollinators to get rid of lawns. Confused as to why state counties are not doing more.
I think that's a really interesting question. I think probably the person posing the question is right that the benefits of that might be more ecological than they are in water savings. And you get some nice water savings, but the urban sector is relatively small in its water use, and quite often I'd rather have their money than their water for environmental impact. But as the questioner mentioned, that there are some cases I think where there's some definite direct ecological benefit for fauna and flora in the urban areas in some conceptions of it.
Yeah. Anyone else got maybe a last quick question? If not, then join me thanking Jay for taking the time and giving this nice overview. And we will be taking the month of December off, but look out for our announcement in January. Have a wonderful rest of the day, everyone. Take care.
Thank you very much. Happy Thanksgiving.
Happy Thanksgiving.